Hi grade 12s, welcome to the lesson. We're going to be working through the consolidation exercise from our textbook, just really looking at all these juicy function and inverse questions. Let's get stuck right in. So, given the function f of x is equal to, negative root 3x, and some of you are going, Claire, why would you start with this? Because we are consolidating grade 12s, and I know that we've worked so well through this section, and we really need to just push ourselves a little bit. And plus, this is not too hectic. The thing is, why this is a bit weird, we're obviously used to, a lot of the time, the original function is the parabola or the exponential function, and then we work to the inverse, right? But here they've actually given you the inverse of the parabola with a restriction on it. So I'm going to just quickly draw this scenario. So if they had said that f of x was equal to plus or minus root 3x, then this is what you would be envisioning. This is what you would be seeing. All right, it's our tipped over parabola. That would be plus or minus root 3x. All right, but they've placed a restriction here. Because it's not plus or minus, because it's just minus, we know then, all right, a portion of this parabola on its side has been removed due to a restriction. So what part would we get rid of? Right, and it would be this part here. So you can imagine, well, you should realize that the arm that I just erased there, its x and y values are both positive. So we definitely not, we can't have that arm if it's negative root 3x, right? It must be this portion that's below the y-axis, right? Think about your reflections work, okay? So that would be your f. This would be f of x is equal to negative root 3x. Let's imagine, okay, so what the inverse of this would be the parabola. So if the full picture of the parabola was there, right, this would be the inverse now. But remember, because there was a restriction placed here, so what is the restriction here? The restriction here was x is greater than and equal to 0, and that y is less than or equal to 0. Right, the range was all your negative y values. So now we know to get to our inverse that we switch x and y around. So this portion of the arm would be the part of the parabola which would fall away. Okay, so it's kind of good to, I don't know, just have a picture in your mind as you're going into the question. Just really helps us. Hey, so now we can actually answer after that. So what's up first? Domain and range. Cool, I've basically done it for us. It's that x will be greater than or equal to 0 and all negative y values. Right, remember to include the origin since, it's not an asymptote, right? It's not like when we're dealing with exponential and log graphs. Determine the equation of the inverse. So it's good to start off with the function as is, right? And then let's do the switcheroo. So we swap x and y around. We're going to square both sides. So you must square that negative as well, hey? You saw that when I drew, it was an arms up parabola. So you want your a to become positive. So x squared will be 3y. We're going to divide both sides by 3. So y is going to be equal to a third x squared or x squared over 3. But there's a restriction. We are only looking in the negative x-axis, where x is less than or equal to 0. I guess we should maybe be pedantic about this. Let's introduce the notation. Right, we're saying here's the inverse with its restriction. Beautiful. Cool. What's up? Question 3. Sketch the graph. Okay, cool. There. Question 3. Just label the origin. And you can label another point on each graph as well if you like. I think that's good enough. They didn't ask us to. Write down the equation of, reflections, lovely. Okay, so the first guy they want us to do is the reflection of f in the line x equals 0 remember that that's the same as the y-axis. So when we reflect in the y-axis, it's that the original point, we multiply the x by a negative. So we're going to have that y is equal to negative root 3 negative x. All right, and then let's just simplify this and put it in correct format. So g of x is going to be negative root negative 3x. Pretty flipping easy. For the second one, we're reflecting in the line y equals 0 or the x-axis. So the rule there is that your x value stays the same, but you multiply your y value by a minus. Right, so what will happen here, if we started off with y is equal to negative root 3x, we're now going to have negative y is equal to negative root 3x. Right, and now you multiply through by negative. Let's just put it in the correct format. So h of x will be equal to, right, it will become positive root 3x. Cool, that's it. Well done. Next question. Cool, let's check out this awesome question. The sketch alongside shows the graphs of three relations. So they're not calling them functions yet. F, G, and H. Which one of these three relations is 1-to-1? Not a function. All right, so the 1-to-1 is obviously going to be your straight line graph. And, well, okay, and how do I know that? It passes the vertical line test. It's a function. The horizontal line test, your ruler, pencil, line only gets cut once. All right, so for number 1, your first question would be H is a 1-to-1 function, and G would not be a function because it doesn't pass the vertical line test. That one X value has more than one Y value, and that's when we feel sad face. So not a function. So for number 2, we would say G. All right. Write down the range of F. All right. So we would know it's all going to be all Y values greater than or equal to 0. So we can just read that off the sketch. Is the inverse of G a function? So what do you think the inverse of G will be? Grade 12s. Turn your page sideways. What does that look like? A cubic graph. So for number 3, we would say, yes, it would be a function. All right, so literally turn your page sideways. It's quite a cool way of looking at it, hey? You switch X and Y around. Just think you've switched your axes. Your X-axis become your Y-axis, vice versa. So cubic function obviously passes the vertical line test. So yes, the inverse is a function. Number 4. State 2 possible ways of restricting f so that its inverse will be a function. Your restriction may not cause the range of f to change. Okay, so they're saying pick the restriction where your range is not lost. So we said that the range is y is greater than 0. If I draw the inverse on here quickly, all right, that would be the inverse of that parabola. So which arm do you think we should cut off or get rid of? To not lose the range, we would obviously want to remove this arm. So then what did that arm correspond to? It corresponds to this arm over here. Right, so that's what we would get rid of. So the way we're going to restrict the domain, we're going to say we want to keep only the positive X values. Okay, makes sense. Do you see how you unpack these questions? They actually really aren't so bad. Okay, so the sketch alongside shows the graph of f of x is equal to negative 2 root negative x. The reflection of f in the line y equals x. Oh, sorry, they gave us g as well. All right, so they put down, so the original function here was the tipped over parabola, and its inverse would be an arms down parabola. We can see again that a restriction has been placed, right? I don't see the full arms down parabola. Let me just draw that. I don't see the full arms down parabola, and I don't see the full tipped over version of itself, right? There's been restrictions placed on it. So actually I'm just going to leave those full portions there. It just helps us, doesn't it? It might help us later on. Let's see. Write down the domain and range of f. Okay, so if we're looking at, my colors are going wild now. So here is f over there. All right, so that's domain would obviously be that x is less than or equal to 0, and the range would be is y is also your negative y values less than or equal to 0. Write down the equation of g. Okay, so g is a reflection of f in the line y equals x. So in other words, it's inverse. We need to switch x and y around. So start off with the original function. Y is equal to negative 2 root negative x. Let's do the switcheroo. X is equal to negative 2 root negative y. We're going to divide both sides by negative 2. So negative x over 2 is equal to root negative y. Now we need to square both sides, including the negative, hey? So it's going to be negative x over 2 all squared is equal to negative root y all squared. So x squared over 4. You square the sign, numerator, denominator, is equal to, when you square the square root, you're left with what's underneath, negative y. All right, so now we just need to divide both sides by negative 1. And let's put it in the correct. So we're going to say f of x is equal to negative x squared over 4. What's the restriction, grade 12s? That x is less than or equal to 0. Okay, it's important that we put that restriction down there because we're not looking at the full versions of themselves, right? We're only looking at portions of the graphs. All right, next question. All right, so now we need to do the coordinates of P. My dog is here and he's snoring, so if you hear snory sounds, it's my dog. He's old, I don't want to wake him up. Okay, so there's point P. So we can see that that is the point of intersection of both functions as well as the line y is equal to x. Remember, I would advise you to, if you have to find a point of intersection, don't let your two difficult equations equal each other. Like, rather let one of the equations equal x, right? Let the point of intersection be with the line y equals x and then either f or g. So I'm going to let f equal y equals x. So negative x squared over 4 equals x. Hey, it's easier to work with. All right, so we can multiply through by 4. So negative x squared is equal to 4x, and let's just make a quadratic. X squared plus 4x. So 0 will be equal to x plus 4. All right, so x will be 0 or negative 4. Obviously, it's not that one. So that would be the other point of intersection being at the origin, right? So if x is minus 4, we know then that y will be the same value, because remember it's on the line y equals x. So therefore the point P will be negative 4, negative 4. Pretty easy. Okay, so I mean, you could have chosen to let this equal x and squared both sides, blah, blah, blah. All right, this is the easier version, but you do you. Right, let's see question 4. Which values of x is f of x less than or equal to g of x? So the graph of f is below g in this area and equal to, so at the point P and at the origin. So from negative 4 to 0 would be that one. Cool. Determine the equation of h, the reflection of f in the x-axis. Okay, so f, there's so many graphs. So f of x was the original function, negative 2 root negative x. So now to get the equation of h of x, we reflect in the x-axis. So when you reflect in the x-axis, you times the y value by a negative, which you would then multiply through by, so it would become positive root negative x. All right, remember that this was y equals all of that. You multiplied the y by a minus, and then you times through or divided both sides by negative 1 to get to this as your answer. Fabulous. Here's a picture of my sleeping dog, by the way, just to prove to you it's, yeah, not me making weird noises. Anyway, let's have a look at H. Okay, the sketch alongside shows the graph of f is equal to a to the x. Graph passes through P. Okay, g of x is the reflection of f in the line y equals 0. So the y-axis, and h is a reflection of f in the line y equals x. Okay, so that's our inverse. G is the image of P on H. Express B in terms of A. Interesting. Okay, so they gave us that f of x was equal to a to the x. But if you notice, if we just look at f, you can see that f is your decreasing exponential function, right? You can see your y values are going down. So the decreasing exponential function is usually y equals 1 over a to the power of x, right? As opposed to a to the x. You can see that g of x is actually your increasing exponential function. So actually, a better way of writing f would be 1 over a to the x, and a better way of writing g of x would just then be a to the x. Okay, because that would be the increasing exponential graph versus the decreasing exponential graph. So to answer question 1 then, another way of writing b would be as 1 over a. So we write b as 1 over a. All right, just think about it. They've again tried to, it's a really nice question. I don't want to say they're trying to trick you here. It's a really nice question. It's testing your knowledge around your increasing and decreasing exponential graph. All right, question 2. Write down the range of g. So g would be y is greater than 0. Remember not to include 0 because your asymptote is along the x-axis, along the line y equals 0. We know that the asymptote is there because the q value is 0. The domain of h, so h I can see is my log graph, and even if you didn't realize yet that that was the log graph, right? Even if you're just looking at the sketch, you can see that it's all values greater than 0, but not including, right? X is greater than 0. Because for the log graph, your y-axis, the line x equals 0 is the asymptote. All right, question 3. Write down the coordinates of A. So your exponential functions, when your q value is 0, right? Or even if you say to yourself, okay, I don't know the value of a and b yet, but to find the y-intercept, I would let x equal 0. So let's say you went y is equal to a to the x. Okay, so that's the graph of f. If you went y is equal to a to the power of 0, right? To find the y-intercept, you let x equal 0, you get that y is 1. All right, so the value of p would be, or not the value, the coordinates for p would be, not p, coordinates for a would be 0, 1. Okay, and next up they want us to work out b. So b is the x-intercept of the log graph, so we know we're just going to switch x and y around. So the coordinates for b, I'm just going to put it here, sorry, but all over the show. B, swap x and y around, that's going to be 1, 0. Awesome. All right, question 4. So I'm just going to make space here. What do they say? So now they give us the point P. So now I can talk about P. Negative 3 over 2 root 27. Determine the values of A and B. Okay, so we need to sub in that point on F. So it must go into the equation of F, which is y is equal to A to the X, right? Y is equal to A to the X. So root 27 is equal to a to the negative 3 over 2. Okay, don't panic. 27, root 27 we can rewrite as 27 to the half, right? And 27 is the same as 3 cubed. So we get to this point. We get 3 to the power of 3 over 2 is equal to a to the negative 3 over 2. So from here, maybe it's obvious what the answer should be, but if you're still not sure, this work now to solve for a kind of falls under our grade 11 syllabus, but we are tested it in grade 12, so just be careful. What you're going to do is you're going to raise this base, so you're going to flip that fraction over, so 3 over 2 will become 2 over 3, and remember now you want to be left with a to the power of 1. All right, so by doing this, by multiplying or raising by its reciprocal, right, all of that will become 1, but you need to have it as negative 2 over 3, so that the two negatives make a positive. All right, now we know that if we do something to the one side of the equation, we got to do that same story to the other side of the equation. All right, so I'm going to be left with 3 to the negative 1, so therefore a is going to be equal to a third. Now b, so g of x is now the increasing exponential graph, all right? It's the reflection of this graph over the y-axis. So if a was a third, then b will be equal to 3, all right? Question 5, so I'm going to go over here. Question 5, determine the equation of h. So h is the decreasing log graph, all right? So it's the reflection of f about the line y is equal to x. So if f of x is a third x, then h of x, its inverse function will be log a third x. Cool. You don't have to do all the brackets. All right, that was 5. Last one, write down the coordinates of q. So they told us that q is an image of p on h. So we're just going to flip that coordinate around that they gave us. So they gave us negative 3 over 2, root 27. So this will be root 27, negative 3 over 2. Awesome. Alrighty, let's have a look at this one. Alright, so we have f of x, this guy. So we can see that this is a log graph, and they tell us. And here's its inverse. We know that's the exponential graph. So the decreasing log graph, the decreasing exponential graph is its inverse about the line y is equal to x. Awesome. It tells us a point which it passes through. Find the value of b. Okay, so we're going to sub into our log equation. So y is equal to log bx. So negative 3 is equal to log b8. All right, so now let's rewrite this in exponential form. Your base to the power of 3 is going to be equal to 8. So I'm going to rewrite this as 1 over b to the power of 3, all right, to make that exponent positive, is equal to 8. And now I just cube root both sides. So 1 over b is going to be equal to 2. So therefore b will be equal to a half. All right, so that will be the value of b. Determine the equation of its inverse. So that's easy. Y is equal to log a half. Oops, not log. Y is equal to a half to the power of x. All right, remember we see that it's the decreasing exponential function. So we're wanting this to be a value between 0 and 1, or we could write it as 2 to the negative 1x. That's also fine. All right, determine the coordinates of a and b. So I think in this one, isn't it easier if we figure out b first? I don't know, you should also kind of know what they are. So b is the y-intercept of your exponential graph, which we should know is going to be 1, right? Because we let x equal 0, so the y-intercept is going to be 1. So if we know that b is 0, 1, and we know that the a, coordinate of a, is a reflection of b in the line y equals x, this is going to be 1, 0. Okay, so nobody needs to know that we worked backwards. And that would be, yeah, the correct answer. Oh, now we see question 4 and all the juicy inequalities, and our blood pulse doesn't rise. our blood pulse, our heart rate, our heart pulse, words. We're not going to get freaked out. Okay. For which values of x is f of x greater than 0? Okay, so let me just get rid of. Okay, so for the first one, f of x greater than 0. So that's, where is it? Above the x-axis, above the line y equals 0. Remembering that there's an asymptote at the line x equals 0. So it's actually just between 0 and 1, but not including 0. Remember that that is an asymptote. All right, our second question. Where is the inverse in between? Where's the inverse lying between 0 and including 1? So what they're saying here is you want to look at the y values, right, from 0 to 1, which would be over there. And they're saying, so for which x values is this true? So when x is greater than 0, right? So for number 2, you would say when x is greater than or equal to 0. We can include 0 here, since the y-axis is not an asymptote for the exponential graph. All right, question 3. So here it says, where is the log graph less than minus 3? Okay, so let's look at the log graph. So log graph is this chap over here. Oops. And amazing. Okay, so there's the minus 3 that they're saying. For which values of x will the log graph be below that value, minus 3? So obviously after this point, right, the log graph will be below minus 3. So what's the corresponding x value? Right, when x is greater than 8. All right, I'm not including the inequality there, right? I'm not saying including because the question just says less than, not less than and including. So if I had to say a sentence for this question, for which values of x is the log graph below the value y equals minus 3? All right, that's what that question is saying. Last one here. Let's rock some purple. Okay, where is the inverse greater than 8? So you're saying, but I don't see a value of 8 on the inverse. But I do have a value on the inverse. So if that is 8, negative 3, I know in the inverse, I'm going to have a coordinate, negative 3, 8. So for which values of x is that above, right? It's going to be for all values of x less than 3. So when x is less than, negative 3, that inequality would be true. Okay, so the inequalities aren't so bad. Do you see, I'd rather make a statement from all the signs and symbols that they give me, right? We know what these inequality signs mean, grade 12. Don't get freaked out by them. All right, last question. All right, last juicy question. Now my cat is playing with papers. Stop it. All right, so straight line is y is equal to 3x plus d, and its inverse. It intersects where x is equal to negative 9 over 2. So that is telling you a lot of information as well. Remember that the graphs of f, its inverse, and the line y equal x, they all intersect at the same point. So we know then that if x is not negative 9 over 2, the y value is also going to be negative 9 over 2. All right, remember that f, its inverse, and y equals x all intersect at the same point. All right, so if we know what the x value is, negative 9 over 2, sub that into y equals x. So y equals negative 9 over 2. So we know what the point of intersection is. So obviously that makes answering question 1 super easy, because now we can just sub into x and y. So negative 9 over 2 will equal to 3 times negative 9 over 2 plus d. So negative 9 over 2 plus 27 over 2 will be equal to d. That will become 18 over 2, so d will be 9. Cool. So the y-intercept of my original graph is 9. So y is equal to 3x plus 9. Now we need to find the values of m and c. Okay, well, we just know basically I must just find the inverse function. So that's pretty easy. Because what do we do first? We switch cheroo. So this, by the way, is y is equal to 3x plus 9. So let's switch x and y around. X is equal to 3y plus 9. We're going to subtract 9 from both sides. And we're going to divide both sides by 3. So x minus 9 over 3 will be equal to y. Okay, so that will be the equation of your inverse. So therefore, your gradient will be a third, right? Because if you split that fraction up, it will be x over 3 minus 9 over 3, which will be negative 3. Okay, perhaps I should just show that step. So I'm just going to split the fraction up like this. So x over 3 minus 9 over 3 will equal y. So therefore y will be a third x minus 3. All right, so the value of m, your gradient, is a third. And the value of c, your y-intercept for your inverse, is negative 3. All right, and that's it. Awesome work, grade 12s. I hope you enjoyed the video and that you had lots of success in this exercise. This work is really so, I don't know. I really enjoy this section. It's nice, easy stuff, hey. Thank you, guys. Have a beautiful rest of your day.